All right, welcome to the Ford front mount distributor. So I'm going to go over a couple things. The starter is, even though if it's a 6-volt starter, and I think it says that on here, 3109N-WD, it will start with 12 volts just as well as it'll start with 6 volts. So already you've got the potential of being a 12-volt system. We'll go over to the generator and take a look at that. Like I said, it's a one-wire model, so this is a positive ground system. I'm having a focus problem there. There we go. And so this is the negative terminal, and the chassis is the positive. And although there is this nice strap here around the case, what I think I want to do is run a positive. I want to run this to ground. So that's something that I'll do after I take the camera off. But here's your generator, and you've got 2 wires here. You've got the original, and you've got low voltage landscape wiring in 12 gauge 2 conductor, which is equivalent to a 9 gauge wire. I just happen to have a bunch of this hanging around, so I put some anti-seize copper paste, cut it at an angle, and shoved it up through here, and just made it past all the existing wiring. So we've got, the spark plug wires, the existing wire that goes to the negative terminal on the generator, your isolated terminal, and we've got the existing wire that goes to the coil, which I think that wire's been replaced in the past. So looks a little bit newer than this braided type of wire. So I've added this to here because this is actually a 12-volt generator, and just like when you put in alternators, you want to make sure you have a really good connection back to your battery. So I'm augmenting this with this. So I plan to put a front plate on here and a winch and run it off the battery. So I want to make sure I have a good connection from my generator. You can see I used marine heat shrink, and I wrote NEG on here for negative. I used I think a number 10 size crimp. So you can get yourself some really good crimps. And what I do is I solder the wire. So I use a non-corrosive flux, solder the wire. So I've just got one big lump of wire. I shove it in there, crimp it, and then heat the terminal end with a pocket torch, and eventually that heat travels up here, and then I feed more solder down here, and I use a silver bearing solder, which is not your typical electrical solder, but it's low temperature melt. It's very easy to work with versus the electronics solder that's available. You can see we've got a little leak here from our radiator hose. Looks like radiator fluid. Yeah, it's radiator fluid. So I will be replacing this hose anyway. So the thermostat on here is supposed to be in the hose, and I've got a new hose and I've got a thermostat. The thermostat off a 1970s Renault, I think, or Fiat or something. You can look this up. I'll put a link in the description. Opens at a lower temperature because originally this was meant to be cooled with alcohol, which is a higher boiling point or something. Anyway, when you use a straight coolant on these, you should use a lower temperature thermostat. So that, I'm not showing that in the video, but that's something I'll do before I put the lid on it. You can see this has been replaced here. So the electrical, we've got negative terminal from the battery, negative terminal to the starter, negative wire from the battery. This has got to be 12 gauge or possibly even 10. This is stock. That runs from here up to our electrical. We've got, it runs up to, where does it run up to? It runs up to here. So because we're dealing with a positive ground system, you flip the battery and the load connection. So this is an ammeter, a modern ammeter. It's got a classic look to it, but it is lit. Again, I'm trying to focus. There we go. And so it's labeled battery positive, load positive, but you need to switch your battery and your load because you have a negative ground system in order to get the correct reading on here. So this is from our generator. Remember that other wire I showed you? This is GEN from the generator. And then off of here are all our switched, excuse me, make sure I got this right. Yeah, off of here are all our switched loads. And then this goes back to our battery. So don't be fooled. There's our heavy wire to our negative terminal on our battery, and this is just a supplemental wire. It's only 14 gauge, but it really should be another one of these massive fellas going from here back to our battery. And of course we have the cutoff down here. So we've got our generator wire. Again, it says gen there. And, you know, we've got our wire from our generators here. It goes to the cutoff. And then we have this wire that's marked gen that runs from here up to here, up to our ammeter. So let's see. So this is all our switched loads, and this is our battery. So what we can turn all these loads off that are coming off of this terminal, such as the ignition, such as the headlight. We'll go over that in a second. Such as, you know, whatever else has a switch on it. If it doesn't have a switch on it, we need to put it on here on our ignition terminal. So remember, this is straight off of that generator post to the ignition switch, and then off of here we have our non-switched loads. So non-switched loads would be like the dash lights here and over here for the 2 gauges. It would be this little cigarette lighter thing that I have here with a USB. You can't see this when the cover's on it. You can access it, but it's not visually obtrusive. Got a piece of, looks like 2-inch aluminum L that I've drilled 2 holes. Remember, there's those 2 cone-headed screws, and here I've just replaced them with hex bolts with locking washers. Nice big hex bolts. I think these are 9/16 drive. 13 millimeter wrench will work on those. And the so this is where the original pressed paper little coily thing that rots out and rusts and people throw it away, and then they jumper it, so they have no resistor on their coil protecting their 6-volt coil, because this is the original, or this is a stock 6-volt coil up here in the front. So originally this is sold as a 6-volt generator, but it's not. It's 12 volts. Okay, so we're a 12-volt positive ground system. So what we need to do to make this work is we need to add another resistor in line with this one, so that we have 3 ohms total. So 12 volts divided by 3 is 4 amps. So each one of these is an ohm, and I think they vary depending on how warm they're running to fluctuate the amount of current going through the coil, you know. So you end up with the right amount of current at the coil. So on a 6-volt system, you just use 1 resistor, and these are the same resistance as those crappy little OEM Ford resistor type deals that are like pressed. They look like a PCB with a little coil. I'm sure you've seen them. You can look them up. This is the other style of resistor. This ceramic one is obviously much more, it's encased, it's much more durable, it's got a nice fat bracket to mount it. So I've got the first one I put on down here with the, let's see what we got. So this runs off to our coil. Remember that wire was replaced, the one that goes to the coil, and that goes off to our coil. Then we've got a jumper wire that goes from here to here, just a 1/4 inch insulated spade terminals. Again, this is silicon wire, this is 14 gauge. And then we've got the switched power to the coil. There's our switch output here, runs over to this terminal. So the power goes from here through one resistor, through a second resistor to the coil. If you have a 12 volt coil, you could use one resistor instead of two. But you should always have a resistor in line with the coil, because those coils do not have internal resistors. A modern coil might have an internal resistor and not need an external one, but these style do not. One of the things that I found is interesting, and I don't know if it's the ammeter or the oil gauge, but when you get a new set of these, and I found this true on a Ford 841 1965, same issue. I think it's the ammeter. The diameter of the ammeter is slightly bigger than the opening, and to address that, just take a flap wheel. It's a drill bit that has a bunch of little pieces of rough sandpaper attached to it, and just go around in a nice even circle around the inside, and that'll open that up slightly, and then you'll be able to put your gauge in there. It's something I've run into on 2 tractors now, so I know it's got to be a common thing. I think that they made the original Ford ammeter a little bit smaller in size. Maybe so you wouldn't mistakenly put the wrong thing on the wrong side. I don't know. So these are just mounts for this. It's not electrical at all. You've got your terminal. I've used copper grease on here, okay, and I've used Wirefy crimps, except for like here, but I've used like Wirefy crimps. This was already here. Just show you an example of the Wirefy crimp. Here's one here. It's a marine grade crimp that has hot glue on the inside, so when you heat it up, it really seals the connection. But even so, on my silicon wire, I use that same non-corrosive flux. Nokorode is the brand, but you know, there's all kinds of flux out there that's non-corrosive. Don't use regular plumber's flux. And I solder the end, so I've got about a 1/4 inch of wire. And that's so that when you crimp it, all those little fine wires, that there's a really strong mechanical bond to that. It's just best practice. You could argue it's not needed here, but... And again, the crimper I use is not the Wirefy crimper, but it's the generic Chinese equivalent. There's the brand name on it. I'll try to put a link in the description. But these are exactly the same as the Wirefy, and they're $16, $17 instead of $40 or whatever Wirefy charges for theirs. But I do have genuine Wirefy crimps. They've been really good. So let's take a look at the light switch. This is just a toggle switch I had hanging around that popped right into the, looks like an ignition switch. You know, put a key in here, type of deal. So middle is off. If you flick it up, it's going to energize this wire here. So the feed for this is this brown wire, and the brown wire is going to the switched loads terminal, right, which is coming in from the generator cutoff. And so as long as it's a switched load, you can put it on that terminal. So when the tractor's off or on, you can turn this on and turn on the headlight. So these lights in here are multi-voltage. They can do 6 or 12. They seem to handle 12 volts just fine without burning out. So there is a screw in here and a hole in the side, and this is an insulative cover. You can see I kind of chipped it off. But you take a fine wire and strip it, send it in, screw it down, and if you need to change the bulb, you can just pull this out right there. You can take a screwdriver and pull that out and change the bulb. So, and it does give you a nice little light around the dial when the tractor's running. It also gives you an indicator that, hey, your ignition is on, because that will not light up unless the switch is up. Because this is a non-switch load, so it's going through this ignition switch. It doesn't have a separate switch just for the lights here, like this does. Down is a potential for another accessory. I don't have it wired up. Just have a THHN piece of wire I had laying around at the time. Just insulated, but that's potentially another accessory. I'm not using it right now. So there's not too much to it. There's no external regulator. There is a, well, the way I understand it with these generators is when you get them, you turn it down to the lowest setting. And as the brushes wear down, you may have to turn this up. There's a slotted screw on here that turns about 90 degrees from here to here, and there's a little high-low printed on the on here, like embossed. You can't rub it off. It's part of the metal. It's part of the stamping or the casting. And you turn that up or down to regulate the voltage coming off of here, and low seems to be the best setting for 12 volt. And so on these, you'll notice there's a little tang. Let's see if I can get this battery up and moved out of the way. Hang on a second, folks. Let me just pause. Okay. There's a little tang there that's supposed to be a stop for when you have the stock 6-volt battery, which is like over $200. So I've got this thick material recovered from a floor mat from a vehicle, I think. I just cut it to size, and I put that over that, and I'll show you how to put the battery on. All right, so this is a battery. It's a group 24. No, it's a group 27. It's a 27 DCM. A group 24 would probably fit in here and be totally adequate size, and it would only come up to here. They're not as wide, so you wouldn't have to make the modification I'm about to show you in order to make it fit, but you would have to tie it down somehow or put something in here as a spacer so that it doesn't move around. So because it's a positive ground system, I have no problem having this positive terminal so close to the bracket and the hood and everything else, and this terminal pretty close to the metal. This one, however, is pretty far out, and if you had a group 24, it would be a little farther in, but it would still be away from, causing you any trouble with shorting out this with the metal. And you can see I've kept this little cap on here again as a protective measure because, just keep it away from your metal hood. We'll take a look at that in a second. You can see the battery when it goes in all the way, when you've got it kind of lifted up a little bit on that bracket. And this is really important. Like I say, I pause the camera, but you lift up on here, and then you take your other hand and you push on this one, and you can see how the battery is kind of tilted at an angle, and that's fine. A little bit of an angle is fine. It will end up being about a 1/4 inch past the shoulder of this bracket, and it sits right between this bracket and kind of the bolt on your oil pressure there. So it's not going anywhere. I'll show you the modification to the hood in a second. All right, so this is the hood, and you can see I've, with an ankle grinder, flap disc, or grinder wheel, I just removed about maybe 3/16 of material off of here, and that braces the battery from going anywhere once you get the hood on. Let's see if I can show you where on the battery it was. I think here I was trying to get it in before making that modification, and now that modification's in there. It's kind of scraped up the shell of the battery a little bit, but yeah, so that goes in right about here, and it holds the battery in from moving anywhere. Like I said, if you use a Group 24, it's maybe easier, cheaper. These are a little over $100. Group 24 is about $100. If you get the 27 or 24 DCM from O'Reilly's, it's an East Penn State manufactured battery. It is not deep cycle. It's false advertising. It's just a starter battery that's inexpensive. And so when you put that bracket up there, it's going to hold this whole thing in. It's not going to go anywhere. So I'll discuss this. Is just a generic radiator thing. There's a hose that runs on top of the gas tank that's 5/16. You need about 5 feet of it. One end runs in here when you put the top back on. The other end runs over the gas tank, but in front of the radiator, and drops down over here to this bracket, which has been bent, unfortunately. I'll bend it back. Just a little aluminum bracket. And all that does is it keeps that hose from getting anywhere near the fan. And the hose runs down here, and you put an elbow on it, maybe a barb with a 1/4 inch to 1/4 inch to 5/16 compression fitting on the end, and then you've got an overflow for your radiator. So that's it. That's all the electrical. The cutoff is new. They do make a solid state cutoff. You can look into that, but I don't know if they have one for 12 volts. I know they have one. I think they have one for 6, but I don't know if they have a cutoff for 12 volt solid state. So that's just a stock style cutoff. The purpose of the cutoff, if I understand it, is so that when the generator is no longer turning, it cuts off the connection. It's like a switch, but it's driven by whether the generator is running or not. So when the generator is not turning, it opens up, and that stops power from backfeeding into this terminal, and the generator needs battery power to excite the coils on the inside to generate electricity. So if you had the thing not running and the battery was directly connected without the shutoff, you'd kill your battery. So to prevent that from happening, that's what that purpose of that cutoff is, that round thing underneath there. But you notice there's no 3-terminal regulator because all that's done inside the generator. And this is sold again as a 6-volt generator. I'll put a link to it. It is not 6 volts, and like I said, I just noticed that there is no, I would like a dedicated wire from here to the ground, so I'm not depending on the chassis as a ground. I found, for instance, when I was putting the headlight in, not to trust the internal wire and instead run a little wire out of it to the to here to make sure it's well grounded. This is a PAR 36 LED. I think it's either 3500. I think it's 3500, and I think it's 60 watts, 3500 Kelvin. So it's kind of on the warmer end of the spectrum. It won't totally screw up your night vision, in other words. It does work. It goes up to 36 volts, from 9 to 36 volts. So, if your voltage is varying on your generator a little bit, which mine's pretty steady, between 12.5 and 13.6 or 8 volts, then, you won't have a problem burning that out. And so this has a wire that goes back, that slots into here, and the advantage of that is if you pull the hood off and you forget to disconnect this wire, the wire just pulls out. So yeah, there's a couple things you need to make sure you do on this. Is disconnect the hose before you pull the hood off, disconnect the fuel line. I have a fuel line that will just slide off of here. It's got a spring clamp just like this, so in case you forget, it just pulls off. It doesn't damage your your fuel system. This one, same thing. On this end, it'll just kind of pull off of this bottle, because I don't actually have this set up yet. As you can see, I don't have the little elbow at the bottom. But this having the battery mounted in line with the engine, whether you have the group 24 or 27, gives you room to put this bottle and just barely be able to, get in there and access this cap if you need to check the levels or refill it or whatever, and hang it off the side of the battery. And like I said, the battery's not moving anywhere, so this is perfect for putting it in there. So if you ever wonder where to put your bottle, it clears fine. So that's all there is to it. I'm going to go ahead and put the lid back on, but before I do that, I'm going to run a positive wire from here, at least to somewhere. I mean, yes, there's this painted bracket, blah, blah, blah. There's this thing here that's clamped onto the generator. But, at least run off of some terminal on here, from here on the generator to somewhere. I don't think I'll be able to fit another wire in here to run it all the way back to the battery, but let's do that. One thing I forgot to do, and then, and put my new radiator hose on. You can see this got kind of chowdered up in the past somehow, and it's starting to just disintegrate. So put my new radiator hose on and put my inline thermostat in there, and then we should be good to go. It runs good, runs like a top. I've had the deck off and cleaned it up really well. Cleaned with the valves just by using some didn't refinish them or whatever. I just lifted up each valve by using the hand crank that you can buy for this. It's like $15, $17. When you do get that hand crank, you're going to have to machine the little little nipples on it that engage with the motor, because you got to grind a little bit off each side in order to fit it through here. But you'll fit it through here, and you use that to just manually turn the engine over in small increments to get those valves to lift, to get around the surface of them and clean them up, because they've got to seal in order for you to get a compression to get the thing to run. Once it's running, you can run some cleaners, system cleaners through there and stuff, and further clean it up. But this thing has plenty of power for being a little 6-to-1 compression, 25 horsepower tractor. Really no complaints. Like I said, I've replaced basically the electrical system, and I've also done it on that Ford, which, if I haven't uploaded the video to this channel, I will. And that's it for the electrical. It's a pretty simple electrical system. It's a great way to learn on stuff. You can see how useful that is. So I'm excited to get this thing back in operation and get to use it again. So thanks for watching.